healthcare, and we will see various aspects of it and how we can use this federated machine learning in healthcare. So yeah, I would like to share my screen. So I hope everyone can see my screen, right?
Yes, sir. Yes, sir.
So is it visible, Ganesh?
Yes, sir. Yeah, it is loading. Yeah, yes, visible, sir, now.
Yeah. Okay. Thank you
Visible,
very
sir.
much. Yeah. So let's start today's session. So I hope you found yesterday's session very helpful, and I hope you will find the same as well. And you must have covered the basics of federated machine learning yesterday. But yeah,
Yes,
still
sir.
we
Yes,
will
sir.
have a quick recap of the things you covered yesterday, so that you can have a strong grasp over the topics. So yeah, today's topic will be federated machine learning in healthcare and enhancing privacy and collaboration. We will see like how we can make our data private and we can work collaboratively and see the effect of this federated machine learning in healthcare. So yeah, what is federated machine learning? Like, let's break this word federated machine learning. Federated itself says, if you see the English meaning of federated, it's like group of organization or group of countries or region. As you have heard, like India is a federal state, so it is combining from different states, and they are working collaboratively to make a country. So that is the concept behind this federated machine learning, in which we have various servers or we have computers that works collaboratively and try to achieve a main task or try to build a model. And yeah, this is federated machine learning. So yeah, so as its slide also say, it's a decentralized machine learning approach. So we will see what is decentralized and all of these technical things in. And in federation, like in machine learning, in conventional machine learning, what we do is we have a system where we gather all the data and train a single model. So federated machine learning is a different technique, you can say, to apply machine learning algorithms. So the algorithms will be very similar, almost same only, but the techniques will be different, and a few extra things will be added to make sure the privacy. Hello. Yeah. So to make sure the privacy, we can make our data private and the model also, so that nobody can invade in our data. So yeah. So yeah, this is the difference between machine learning and federated machine learning. Machine learning is we have a centralized training process. By training process, what would I say is we have a single server or single system in which we gather all the data, and we train a single model. We will do hyperparameter tuning and all those stuffs to improve our model's efficiency. But suppose if you working in a healthcare, and so we have different hospitals like Apollo, we have Medanta, we have Fortis. So they must be having data. Suppose you want to predict if a person has cancer or not, so they must be having different data, and they don't want to share their data so that you can consolidate on a single system, so they are not agreeing. So to ensure the privacy of the data, so you will train their local models, and you will aggregate those model output, and will form a global model. So this system is called federated. I hope the difference is clear between machine learning and FL, and I think you have already covered this in your previous session, I guess. Yeah. So regarding the data privacy and security also, as I mentioned, in ML, data is often centralized for training. By centralized, I mean it's on a single system only. So yeah, if somebody invades in the system, they can easily steal the data and may hamper the security of the system or the model. But in FL, as the data is distributed or the models are distributed on different system, even if you hack one of the system, that consists of maybe only 10% data, so your 90% data will be safe. So yeah, this is how the federated machine learning is very different from the conventional machine learning. So yeah, this is a simple architecture where you can see like how this federated machine learning works. So see, this is first, you can see this is a community hospital, and this is another hospital, maybe research medical center. This is cancer treatment center, and they are working collaboratively to work on a single project, maybe a cancer prediction model they want to build. But yeah, along with it, they don't want to share their private data. So here comes the concept of federating machine learning. So they will train their local model. By local model, I mean their own system. Like community hospital will train the local model on his data, and yeah, as research medical center will also train its local model on its private data as similar to, and also this cancer treatment. Then they aggregate or they combine their model and yeah, make a single global model. We will see this in detail, like what this centralized and decentralized in detail, but this is an overall picture. I hope you guys are getting it. So yeah, architecture of communication, that is centralized and decentralized. Okay, so we will see this. So what is centralized system? So this is the simple architecture of centralized system. So the federated machine learning can be centralized also, decentralized also based on the architecture. So this is the architecture of centralized federated learning. So first, global model, that is here you can say the number 4, this one. So first, a global model is sent to the client devices. Devices, I mean the local devices, like the hospital 1, hospital 2, and hospital 3. Second, the global model is updated with the client data. So the global model is updated. Third, the revised model is sent back to the server again. So this is the common server with everyone, or you can say every hospital is interacting with. And finally, the local model are averaged on the server. So whatever the model sent by these individual hospitals, so they will average the model and yeah, create a new global model. So this process is iterative in nature. So further, again, the model will be sent to hospital 1, hospital 2, hospital 3. Again, they will train their local model, and again they will send to this common server. So here you can say a common server is there. So that's why it is called centralized system. I'm not talking in terms of the data, I'm talking in terms of the training process. So federated machine learning can be centralized also, decentralized also. So then we have this decentralized system. So in decentralized, so how it is different from centralized? Here you can say the each hospital is also interacting with each other. So that is the main difference, or and also will not find the main server here. So that is the basic difference. So it is the architecture of decentralized federated learning. So the first, local gradients are updated. By local gradients, I mean the weights. You can say weights are updated at each individual hospital. You can say. Second, these gradient are sent to the selected parties. By parties, I mean the different hospital or the clients. Then the third, the model is updated with the local data and gradients. And lastly, the updated model is sent to the other parties. So maybe 2 or 3 or maybe 4 hospital, they can combine their model and they can make a global model, you can say. So this method is usually preferred because it involves the exchanging of local models, which are aggregation of a large quantity of data. Because uh, here in hospital 1, they must be having their own data, and in 2 also, hospital 2, they must be having their own data. So it's an aggregation of the large quantity of the data. Then we get the global model. But however, decentralized federated learning works on the concept of mutual trust. So by mutual trust, I mean there should be trust between the parties or between the clients, so that they can initiate this learning process. So this can also lead to some few drawback. So an example is the decentralized cancer diagnostic system. So among hospital medical institution, so each hospital distributes the local model that has been trained with patient data and acquires the global model for future diagnosis. So in summary, what I can say, the difference between the centralized decentralized is, so centralized federated learning has the central authority for aggregation, that is the main server, and communication centralized to a server. So you can say all the communication will be handled and will be communicated with the central server only, and also single point of control. Single of point of control means the main server will be controlling everything. The worker node, we can say the worker node, I mean the hospital system. They might be having their local system, so that is also called as worker nodes. And so but the major disadvantage of centralized federated learning is, so there is a single point of failure. So if the suppose if the server fails, so everything will be shut down, and the process will be stopped. So generally decentralized federated learning is usually preferred. So and decentralized federated learning, you must have learned this. Local models communicate directly with each other, so they don't need to communicate with the main server, because there is no main server here. So distributed control among local models, and yeah, potentially reduction in communication overhead also, because we don't have to communicate and respond to the servers or client's query, so there is no communication head also. So yeah, so I hope you have understood the difference between centralized and decentralized. So federated machine learning can be centralized also and decentralized also. So it depends on the requirement and the problem statement, which approach you want to, proceed with. So yeah, so this is the main difference. So there are also different way to have federated machine learning. So we have that data partitioning. So on the basis of like how you divide your data, so it is also an aspect to have like different kind of federated machine learning. So up till now we have seen these two, centralized and decentralized, based on the training. Now we will see like on the basis of data partitioning, how we can partition the data and have different federated learning models. So basically we have three types of federated learning on the basis of data partitioning, that is horizontal, vertical, and the third one is hybrid. That is, I think it is very much understandable that it is a mixture of both horizontal and vertical. So yeah, horizontal federated learning. So it involves the data that is shared horizontally. By horizontally I mean like the feature spaces will be same. By features, I mean the variables inside the data set, those independent and dependent variables, the column names, that will be same. But the sample will be different among the each worker node, or you can say local systems. So each group in horizontal federated learning has access to the entire feature set. So yeah, as I mentioned, the feature set will be same in all, and allowing them to train their local model using their data set. So they will train their model on their data set only. And yeah, after that all the parties exchange their model updates with an aggregator that can be average, or maybe their median. So it depends like how, which approach you take. You can take out the median of the models, or you can take the mean of the or you can say average. Then you can generate a model by combining the updates. So yeah, in healthcare industry, the horizontal federated learning, so we can see have a different applications. Like it can be used in disease prediction diagnosis. So you can predict a disease, like I mentioned, maybe diabetes you want to predict. So you can divide your data in a way that the each model will have the same feature set but different samples. Like suppose if you have 10,000 of rows in a particular data set, you can divide the data set like maybe it depends on the how much system you have. You can take like 2,000 each. Suppose you have 5 systems, you will divide the sample on the basis of rows, and you will divide the data into 2,000, and each model will get 2,000 rows and will train the data and will aggregate it. So yeah, another application is like clinical trial optimization. You can have different trial in clinics, and see like maybe which trial is getting us the optimized result. And collaboration in model training ensure that training trial recommendations are based on an more comprehensive understanding of diverse patient characteristics. And another application is drug discovery development also. So when you start developing the drug, so there are some hypothesis testing also. There's alternate and null hypothesis testing. So when you reject the null hypothesis, then your drug discoveries, you can say, is completed, and you can deliver your product in the market. So horizontal federated learning is useful in that case also. So then we have vertical federated training. So in vertical federated training, what is the difference? Basically, vertical itself says the columns, like in a vertical rows. So the columns will be different, but they have the similar samples. Suppose you have 10 columns. For an example, let's take a short data set. You have 10 columns in a data set. So in one model, what you will do, you will pass only 1, 2, and 3 column. And in different another system, you will pass maybe 2, 3, and 4. And on the third model, you will pass column number 1, 5, and 7. So it's like a random forest. If anybody knows, in random forest also we use max feature bootstrapping we do. So the each model will have duplicates of columns. So but the different columns, as I illustrated with an example. So this requires a different kind of training architecture when compared to horizontal federated learning. So, and it may or may not be involve a central server, like I said, the centralized federated learning, or a third neutral party. And vertical federated all applies to the collective situation in which individual parties do not have access to the whole collection of features. As I said, so different parties, they will have different features. So no party will have the complete collection of the features and labels. So those are unable to train a model locally using their data set. So yeah, because nobody has the complete data set or complete feature set, so they will not be in a position to have the model which consists of all the complete data set. So they will train their individual on their individual data set only. So this is the difference. So application of VFL stands for this vertical federated learning only. So in clinical decision support system, so healthcare institution, they can collaboratively build clinical decisions and support models by combining information from different sources, such as EHRs. So those who have this medical background, they must be knowing this electronic health records and medical imaging data, where they have different pics, or you can say like in brainstroke we have different images of the brain to predict something. So that is also an application of VFL. And drug interaction also, and adverse event prediction. Drug interaction, I mean, so when you consume two drugs, so when you have two drugs, so the two drugs, they should not interact with each other, and will not form any other compound. So in that also we have this application of VFL. And genomic data analysis also, we can use VFL. And disease surveillance and outbreak prediction. So outbreak prediction, it was very much used in the COVID-19 analysis. So basically to prevent the outbreak of this COVID-19, so they basically used vertical federated learning also. So these are some of the application of this VFL and HFL. So yeah, in the diagram also you can say, so above example is of horizontal data split, where you can see the person one, so they have same feature name, age, blood group, and person two, name, age, blood group, and person three also name, age, blood group. So the feature name will be same. And in second, suppose you have two parties, maybe a blood bank and hospital bank. And in blood bank, suppose you have name, age, and blood group. And in hospital database, you might be having maybe name, age, maybe their height, maybe their weight. So you combine both the data set from both the parties, and will form the model. So this is the basic difference. So overall, in a summary, so horizontal federation learning, we can say the samples remain the same, No, sorry, the features remain the same, but the samples will be different. But in the VFL, that is vertical federated learning, the samples will be same, but they will have different features name. And the features, I mean the column name basically. So yeah. So let's move on to data pre-processing. So data pre-processing means cleaning the data. So this is the very first step when you get the data. So we have a very famous saying in data science field, GIGO. GIGO is a short form of garbage input, garbage output. If you feed garbage input to a model, so you will get the garbage output. You will not get the good output. And QIQO, that means quality output. If you are feeding a good quality of the data by cleaning it properly, then the model output will also be good. So 70 to 80% of the data science, or you can say data scientist person, he will spend on cleaning the data, because if the data is not good, you will not get the good model. So, and also apart from these technical things, so before starting any data science project, you must have this domain knowledge also, especially in healthcare. So while you should not or you can't remove the columns directly based on your technical skills, or you can say correlation numbers and skewness, you can't directly remove those columns. Maybe those columns is might be helpful. So you must be having the domain knowledge also. So there is always a one person who will sit beside you and see like which columns are necessary or which columns are not. So uh, so one should have medical knowledge, and yeah, also know the AI techniques to clean and normalize the raw patient data. So normalization is also done, because you can't feed if you don't normalize the data, then one column will dominate over the other. So you must normalize the data also, so that you can have all the values in a particular range and in a particular standard. And also the data from the hospital includes, it might include the outpatient or inpatient in prescription, outpatient, inpatient EHRs, and metadata. Which is metadata? Metadata is like, you can say the information about the data, maybe column name, and which table consists which columns, which data. So it is about the information about the data is called metadata. So here I have small snippet code. You can see like, so here we are importing the libraries, and so we are creating a virtual workers. Virtual workers, I mean the two parties I'm creating. Maybe one is hospital one and one is hospital two. And then we are defining a simple neural network. So in simple, I think everyone is familiar with neural networks. So what we will do, we will create a class of neural network in which we are defining a constructor, and inside the constructor, so we are creating two layers which consist of eight neurons, one, and second layer one neuron. And on neuron we are applying sigmoid function. So sigmoid function is basically used in the case of classification problem. By classification, I mean which has output like true, false, zero, one, yes, no, something like that. So we use sigmoid function. The use of sigmoid function is to um, convert any value in between 0 to 1. So it converts any value in between 0 to 1, and you can find out the formula on Google also. So it is 1 divided by 1 plus e raised to power minus x. So whatever x you will pass, it will directly convert it into a range of 0 and 1. So next we are defining a function to train a model locally on a worker. So we will pass the data, and we will define the epochs, that the number of iteration the gradient will change, or the, you can say, the model parameter will change. So we will set the epochs as 5, and it's a function to create a local model. Okay. So then we have another function to perform federated averaging. What we will do is we will take the local models and we will average. So here you can say average is also sum divided by length. That is average only. That is sum of observation divided by how many models are there. You will average each and every observation. Then this function is to test the global model. So after averaging the model, you should test the global model how it is performing. So that if it is not performing well, you can again send the updated model to the local models, and you can update the global model again and again until you get a generalized model. So yeah. So now in this we are loading the healthcare data set. So we are generating a fake data set here, and we will data set will be transferred to the each worker node. Each worker node will be hospital 1 and hospital 2. So here we are creating a data loaders for each hospital. And yeah, in train loader hospital 1 is our one hospital, and train loader 2 is our second hospital, in which we are passing the data. And also we are creating the batch size. So whenever you train a neural network which consists of lots of tensors, so you should have a batch size. So if you increase the batch size, so the training will be fast, but the computation will be very high. So you need a good server with high GPU and good specification. If you decrease the batch size, so training process will be slow. But so yeah, so you have to trade off between this batch size. So it's a hyperparameter. And means every time the data is going to a model, so it will shuffle or not, like at each epoch, so the rows will shuffle or not. So this is the, so it's a good practice to have shuffle equals to true, so that we can have the diversity in the model. So here we are creating test loader global, so in which we are passing the test data set. So here, create a global model and send copies to each. So we will create this net is a class. This you can say this net is a class. So here we are creating a simple neural network and passing it to each worker node, that is each hospital. And we are also defining a loss function and optimizer. So optimizer might be SGD, that is stochastic gradient descent, and it can be momentum also. And we have NAC also, we have ADAM also, we have different optimizer that we have to optimize and reduce it to a minimum, so that the model achieve the global minima. And at the global minima, when we can say so it is performing best and giving the minimum error. So here, train local models on each hospital data. So we will train our local model through this function, and we will pass the uh, training data and the optimizer and everything to train the model. So here from the this code, uh, so those two parties models will be trained. And yeah, through this federated average, the function we created here, this federated average. So we will take the input, the updated model, this local model 1, local model 2, and we will average with the global model. And through this code, this test global mode, what we will do is we will test the global model. So I think this process is clear with the code, as the it was a theory, like how it is going and how it is performing this centralized, decentralized, and this process I wanted to show you with the help of a code, like how it happens. So yeah, so yeah, this is the code. I hope everyone has understood. So if nobody is understanding, or if anybody has any doubts, they can interrupt me, and yeah, they can definitely ask their doubts. So I want you to have gain maximum from this session. Um, okay, so I hope everyone has understood this. So okay, so we need different tools, right, to perform this federated learning. So when you use a neural network or simple machine learning, so you use different libraries, right? TensorFlow, you might be using, some might be using PyTorch, and in simple machine learning, you might be using the scikit-learn library, and different libraries, pandas and NumPy. So similar to this machine learning, in federated learning also we need different tools. So yeah, but the tools are different from the traditional machine learning, because it's a different technique. So first comes is this TensorFlow federated. This we call as TFF. This stands for TensorFlow Federated. So it's an open source framework to perform machine learning and computations on localized information. And TFF allow developers to simulate federated learning algorithms on the model and data. And TFF's interface are unionized in two layers. Basically, it has two layers. One is federated core that we call FC, and federated learning FL. So these are the two. So federated core API is the foundation layer upon which which is built the federated learning API. So this is a strong functional programming environment that involves a combination of novel federated learning algorithms and TensorFlow with distributing higher revelation operators at the core of the system. So, and whereas federated learning API that I told you, there are two: federated core and federated learning APIs. Whereas federated learning API is at a high level interface. This API allows developers to to use the existing FL algorithms, and that is training and evaluation in their models. So you should be knowing these terms because these are the tools you will be using. This shift that we have already used here, you can see this. We have imported this shift as SY, and we are hooking the torch to ensure the privacy of the data. There should be no leakaging of the data. So that's why we are hooking the torch. And torch, we have different tensors, so we are hooking and we are trying to make it safe. So these are the different tools. So second one is Fate stands for this federated AI technology enabler. So yeah, it was initiated by WebBank's AI department, and it's an open source project. So this framework provides a secure computing framework supporting the AI ecosystem. It uses privacy preserving techniques like homomorphic, like the same form, you can say, encryption. We will see this homomorphic encryption later on, and secured multi-party computation. I think you have already covered this encryption in yesterday's session. I'm not sure, but yeah, still we will try to see what encryption is. And it also supports, ML algorithms like logistic regression, deep learning, tree-based algorithms like random forest, XGBoost, and transfer learning. And federated ML, Fate Flow, Fate Serving, Fate Board, and Kuber Fate are its six main modules. So it currently supports training a variety of machine learning models, including NN, that is neural network, GBDT. You can say the gradient boosting decision tree, which it's a combination of decision tree in a sequential manner, and logistic regression in both horizontal and vertical federated setting. So I think you must be knowing this now, this horizontal and vertical federated setting. So to ensure anonymity, so it also incorporates safe multi-party computing and homomorphic encryption. And yeah, let's come to this third tool. This is PyShift, that is Python Shift. So it's a secure and private deep learning library that we saw in the code also. So it's a library for answering questions using data you cannot see. So it uses privacy preserving techniques. So what it will do is it will convert the data into some in some encryption, so that nobody can see the data, and nobody can steal the data. So yeah, so like differential privacy, homomorphic encryption, multi-party computation with deep learning frameworks like PyTorch and TensorFlow. So here, as I told you, this PyShift is used to to ensure that that data is converted into encryption, and we can hence save the data from the stealing. So both PyTorch and TensorFlow can be used with PyShift, as we saw with the PyTorch only. So with the TensorFlow library also, we can use PyShift. So it can be installed on a single computer and also on a several computers with the WebSocket API, so used to communicate between the clients. So when we have different computers or systems, so they must be communicating with each other. So usually they communicate with the help of WebSocket APIs. API stand for application program interface. So this is the way different computers they communicate with each other. So the fourth one is Leaf. So Leaf is a benchmarking framework for studying in federated setting, and with programs consisting of federated learning, multitasking mastering, meta learning, and on tool learning. So it includes six databases that cover a variety of topics such as image recognition, emotion analysis, and next character prediction. Next character prediction, like we do in the GPT also, have you see. So in GPT also you can see it predicts and character. So it's a next character prediction. So then we have Paddle FL. Paddle FL is Paddle Federated Learning. So it's again a library, and it provides application in natural language processing, computer vision, and recommendation systems. Paddle FL allow the deployment of federated learning system in the form of, you can say, distributed clusters at a large scale, and it has proven to be of great benefit to the developers. So, and also similar to PyShift, so Paddle FL is also a open source framework based on Paddle. Yeah. Then we have this FedML. FedML is again a different tool. So it serves as a tool for federated learning as well as a forum for FL benchmarking. So its core structure is split into two layers as an FL system. So on-device training for IoT and mobile computers, distributed computing and single machine emulation are all supported. And FedML also embrace a variety of algorithms like decision tree, the logistic regression, linear regression, support vector machine, and also prototypes and databases also for study variability. Study variability, I means the decentralized learning or vertical FL, split learning. So all those things it also incorporates. So yeah, these were about the tools here. So based on the requirement, it's not like you have to use every other tool. So based on your requirement, like what requirement you have, you can always change the tool. And based on the problem statement, you should know the problem statement first, and based on the problem statement you should choose the tool. You can't just blindly go with any tool because every tool is available. So it's not like you will use every tool and or include all of them in your single project. No, it's not like that. Based on your problem statement and based on project, team will sit and will decide, like we'll see the pros and cons of every tool, and whichever giving us the maximum security, keeping the data secure, and not hampering our model performance, then we will choose this tool. And okay, so here we will see some of the application of federated learning in healthcare. So yeah, you can see this prognosis, diagnosis, and clinical workflow. So what is prognosis? I don't know which background you are all. So prognosis is a diagnostic term that refer to assessing the possible, or you can say potential progression of an illness, such as whether the signs and effects will change or worsen, or how quickly it will worsen or stay constant over time. So these type of trend you will see this. So this is called prognosis. So the natural course of the diagnosed illness, the individual's physical and emotional health, the current medication, and other consideration are used to make a prognosis. So okay, so in prognosis we have brain data meta-analysis, that is patient data, related to the stroke prevention is sensitive. So we don't want to someone to steal the data, or it should not be leaked. So it requires the privacy protection. So in this case we can use federated learning, and depending on the tool we can choose the tool according to the requirement, and we can proceed with building the model. Then we have stroke prevention prediction. Stroke prevention prediction, like distributing the you can say imaging data. So brain tumor segmentation. So yeah, brain tumor segmentation. So okay, brain tumor segmentation involves analyzing the medical images which are sensitive. So we have different images of the brain tumor. So in brain tumor, so every image has a subtle difference between each other. So we will build federated learning, and data will be distributed among different worker node, and we'll train the model on the brain tumor segmentation. Then we have diagnosis. Okay, so diagnosis, the description of the type and origin of the certain phenomena is referred to as diagnosis. So diagnosis is used in many different fields to assess cause and effect with difference in the application of you can say logic or analytics and practice also. So one application is multimodal COVID-19 diagnosis. So COVID-19 diagnosis at the edge. So COVID-19 has been a major focus of research in 2019 and 18, especially after this WHO declared it a pandemic in March, I guess March 19. I'm not sure. So with the various activities focused on diagnosis, prevention, and the production of a possible vaccine. So risk identification, touch monitoring, false news identification, emotion analysis, and screening and diagnosis. These were some of the main application of the data sciences approaches, especially machine learning and data visualization technique. So in the international response to the COVID-19 pandemic. And despite major advancement in recent years, so cloud-based healthcare system, they appear to be underutilized due to their shortcomings in meeting the rigorous production, because and privacy also, because they were having the central server, and so they were concerned about the privacy and quality also. So the scientists, they take advantage of this edge computing capability in medicine. Edge computing capabilities, I mean, these worker nodes only. So in medical and medicine, by exploring and testing the ability of intelligent analysis of clinical visual data and a link to the COVID-19 at the edge. So they also enable remote healthcare centers to benefit from a multimodal shared learning model, without having to share any knowledge about the local data's modality or the data itself. So yeah, this is the first application of FL in multimodal this COVID-19 diagnosis. So then we have brain pathology segmentation. So brain pathology segmentation is very similar to the brain tumor segmentation. So medical images of the brain pathology segmentation, they are very sensitive, and they require privacy protection. So federated learning can be used to ensure the privacy of the data, and not hampering the model's performance. Then we have collaborative discovery. So it means distributed pharmaceutical research. So drug discovery involves data from various research lab and pharmaceutical companies and institution. So when data is distributed, then federated learning, as I already told you, is the best possible technique to have a generalized model without gathering the data from all the sources. Then we have clinical workflow. So clinical workflow is often conducted to optimize, consistency in the workflow. So the in a clinic, or you can say in a hospital, so they have a standard workflow. So they should be ensured like the workflow is is very streamlined. So they analyze current framework, and they research a process and its implementation and so on. So these are the some of the application of federated machine learning in in health industry that I told you is prognosis, diagnosis, and yeah, clinical workflow. So let's move on to the next slide. So yeah, so we have challenges also. Beside these, we have different challenges also. So we have privacy and attacks, and we have challenges regards to the uh, regarding the data also. So okay, so first you can say this is adversarial attack, the evasion attack, inadequate model training, gradient inversion attack. So these are some of the attacks, and we will see each and every one in a detail. So okay, so sometimes eavesdropping attacks can also happen. So it is the maybe a competitor or maybe your enemy. They might attempt to intercept or eavesdrops on the communication between participants, aiming to extract the sensitive information or gain the access to confidential model parameter or sensitive data being exchanged during the federated learning process. So there might be a situation where two models are interacting with each other using APIs and all, and somebody is eavesdropping, and they might steal the data, and they might steal your confidential model parameters, and they can use it for their own benefit. They can sell the data, and they can earn crores of rupees in that, and it might not be useful for you also. So that is the first attack. Then we can say we have evasion, or you can say it's another term is exploratory attack. So it is among the most common adversarial attack, and yeah, carried out during the inference time. By inference time, I mean when you are doing the prediction. So then these attacks usually happen. So this setting does not imply any influence over the training data. So they usually people don't attack training data, so at the inference people evade. So in this attack, a competitor or your enemy, they attempt to evade the deployed model by feeding the malicious data samples or collecting evidence from the models featured during the inference phase. Suppose you have deployed a model somewhere, and they are feeding and you have deployed it for the prediction, and somebody is feeding a malicious data, maybe some virus or something, and they can collect your data. So this is the evasion attack that happens usually during the inference time. Then we have inadequate model training. So in inadequate model training, so machine learning models while training, they may involve so much of problems and flaws. So the model training flaws include improper or inadequate training, maybe violation of privacy, model poisoning, or theft. So improper or inadequate learning refers to cases where improper parameters are learned in MLDL models, like learning rate. We have learning rate, that is learning step also we can say, that is denoted by alpha in a neural network. So then we have epochs and batch size. So these are the hyperparameters, and suppose if you are not passing the balanced learning rate, maybe you are giving very high learning rate or very low learning rate. Similarly, epochs, you are passing one, or maybe you are passing like 10,000, and batch size also again. So if you are not passing these hyperparameters properly, then that is called inadequate model training. And yeah, this can also happen. So then again we have gradient inversion attack. So this attack strategy implies that it is possible to recover and reconstruct input data from a gradient knowledge of trained or untrained model parameter. So when you have the parameter, so it is possible to again possible to reconstruct the input data based on the parameter. So people usually if you are suppose if you are having this linear regression model where you have a line y is equal to mx plus c as a prediction, where you have predicted value of m and c. So based on those parameters also, even the people, they generate the data directly, the input data. So this is also again a privacy attacks. So these four are very common. There might be more invasion or attacks besides these four, but yeah, these are very common in in today's scenario. So then we have challenges related to our data. So first we talked about this privacy and attacks. So we will see the challenges also with the data. So noisy data. So noisy data, so noisy data means maybe the data set might be having outliers, or maybe there might be some values very far away from the normal values, and inconsistencies you can say in the data. So it will affect the quality of the model training. So it is another issue. So noises in local data set may lead to inaccurate model updates. So suppose you have two or three worker nodes, they are training the model on different data set, and they are having the noisy data. So when you collect the model update from each worker node, so that might impact the global model's performance, because there were noisy data in the local system. So you should must ensure that you are not having this noisy data in the data, yeah, so that you can have the generalized model. Generalized model is the best model, you can say, is the best performing model. Yeah. So then we have proper improper annotation of the data. So annotation is the labeling of the data. So incorrect or inconsistent labeling of data leading to this mislabeled example in the training set. So misannotation may misguide the model during the training, reducing its accuracy and generalization. Suppose you have annotation by mean, suppose you have a data set of images, you can say, like cats and dogs, and you are labeling the data, and you are labeling cats and dog, sometimes cats as dog and sometimes dogs as cats. So this is not a good way. So your annotation should be, perfect. Cat should be cat and dog should be dog, so that you can have a very good model. So this is another problem, that happens, because when you annotate the data, you get you don't do it manually, because the data is, maybe in lakhs, maybe in crores. So you can't do it manually every time, and you can't annotate the data. So you have different tools, like CVET. There is a tool from Microsoft, and VOT is another tool. So these are the tools to annotate data and in bulk. So yeah, so this is the improper annotation of the data. So it is another challenge related to data. Then we have data biases. So biases in training data, where certain groups are over or underrepresented. So this can lead to biased model prediction. So biased local models may contribute to a biased global model, reinforcing or exacerbating the existing biases. So biasness, I mean, so in the chat GPT also, it was observed that because the data was biased towards the white people, because the dark people or black people, they were very less in the data, so it was biased toward white people and giving the opinion more based on the white people. So there should be no biasness. So, and gender biasness is also there. So if you are, having the male data more in the data set and female, only 10%, you can say. So there is another biasness which is called gender biasness. So we have different biasness, so maybe religion or different biasness. You can Google it. So there should be no biasness also in the data. But yeah, as I told you, 70 to 80% of the time of the data scientist goes in cleaning the data. So by cleaning the data, I means, making the data unbiased, and having the proper annotation, and removing the noises, and you can say removing the null values, duplicates values, dropping the unnecessary columns, and removing the outliers, normalizing. So, it takes 70 to 80% of the data, because if you are not feeding the good data to a model, so hence you will not get a good model as well. So these are some of the issues. Then we have false positive and false negative. So false positive means, you are predicting false as positive. That means you are predicting zero as one. So that value which is false, you are predicting is true. And false negative means the value is negative, but you are predicting is false. So like in healthcare industry, false negative is, most important. Let me give you an example. Like, suppose if a person has corona, and if you predict like you don't have corona, and so it is called false negative. So, it is more dangerous, because you are predicting that person has not corona. So, it might leads to his death also. So false negative and false positive, these should be, less as possible. And false positive means, if a person has um, they don't have corona, and you say corona, so maximum what can happen, the person can go back and take the medicine, in spite he don't have the corona, but still, he take. But false negative, it is more dangerous in healthcare industry. So we can't, decrease the false positive and false negative at the same time. So we have to make a balance, like which one is more important. So in healthcare industry, generally people prefer false negative is more dangerous as compared to false positive. Like both are false, both are, wrong, but you can't decrease um, both the values at the same time. So based on the problem statement, you see like which value, I can trade off with. So in healthcare industry, generally, false negative should be as minimum as possible. So it is generally used in the evaluation of the model in classification problem. So in classification problem, we draw a confusion matrix, so in which we have true positive, true negative, false negative, and this false positive. So these true positive and true negative, they should be higher in number, and the positive and false negative, they should be lower in number. So yeah, so we have to see like which value we have to make the minimum. based on the problem statement. As I told you, in healthcare industry, false negative should be minimum. So inaccuracy in binary classification, where the model wrongly predicts positive or negative instances. So incorrect prediction at the local level may pass on to the global level, as the model will pass on to global level. So it will also affect the global model accuracy also. So we have to make sure the false negative and false positive, they should be minimum as possible. And yeah, that is again this, we have to see like which value we have to make minimum as possible. So yeah, these are some of the challenges and issues with um, the model training. So yeah, so I hope you guys are getting it, and I'm not boring you people. So I know you might be working since morning, and I know it might be boring for some people. Yeah, but still, yeah, I'm trying to clear your concept so that you can apply in your day routine, also in your research project also. So yeah, I'm trying to do that. Okay, so next, let's move on to privacy preservation. So, okay, so privacy preservation, I'm not sure you have covered yesterday or not, but yeah, we will try to cover it. And so we have different cryptographic methods. So one is, as I mentioned, this homomorphic encryption. So what it does is this is a technique basically that allows computation on encrypted data without decrypting it. So this means that the computation can be performed on encrypted data, and only the final result is decrypted. So that means when you have the data, you encrypt it into a certain format so that nobody can understand it. And yeah, even if it leaks out, or even if somebody is stealing it, so he will not able to decrypt it. And when the model is predicting, it will decrypt the model's output automatically. So this is one of the encryption method. This is called as homomorphic encryption. So we have different encryption methods. Then again, we have the secret sharing. Secret sharing. So secret sharing is a cryptographic technique. So where a secret is divided into multiple shares. So we will create a secret, and we will divide the secret on the in different way, and we will distribute these shares among different parties. And different parties means the worker nodes, or you can say the local system we have on which our model is training. So we will divide this multiple shares in in these different local models. And the original secret can only be reconstructed when a sufficient number of shares are combined. So at the end, if you have suppose you have 10 local system, and mm, you will divide the secret key into 10 division. Okay, then you share each and every secret key with different more local system that are 10. And if you combine all of them 10, then only you can get a complete share. Even if you divide 9 and one is not want to combine his key with the another 9 keys, so you will not able to decrypt it. So this is another secret sharing method. So we have studied this homomorphic. So these are the cryptographic methods, this homomorphic secret sharing. And then we have this differential privacy. So yeah, differential privacy is a privacy preserving concept, that aims to maximize the accuracy of queries from statistical databases, so while minimizing the chances of identifying its individual records. So it involves adding carefully calibrated noise to the data to protect individual privacy. So in this method, what you do is you add some noises in the data intentionally, and these are the noises. And if somebody is stealing your data and somebody is taking your data, then he might not having the perfect data set. So this is the method where you add the noise in the data, so that even if it leaks out, so there is no loss in that. So this is the another method. So then we have this SMPC. We say this is secure multi-party computation. So okay, so this is also a cryptographic method where multiple parties jointly compute a function over their inputs. So what they do is they have different inputs. They will create the function of it. So they will pass the function in the model. They will not pass the input, and so they will keep those input private. So that's the computation is performed in a way that reveals only the output of the function. So if you are feeding the function in a model, so it will generate the function only based on your model. So here you are not feeding the input directly. You are first creating the function of those inputs while keeping those inputs private. And yeah, the computation is then performed in a way that reveals only the output of the function. So these are the privacy preservation in federated learning. So and you have to choose wisely which method you have to choose based on your problem statement. In data science, we cannot say like this is the fixed path, or this is the only way to do a problem. So we change our technique, we change our methods based on the problem statement, based on the data set. So yeah, we change. Like those who are from this ML background, they must be knowing this. You must have taught like you can impute the numerical column with only mean and median. Sorry. So no, it's not like that. Yeah, we usually have mean and medium in the numerical column, but yeah, we can also use the mode also in the numerical column. But in the textbooks also, you will see in numerical columns you can also impute the missing values with mean and median also. That is based on the outlier. If it has outlier, then yeah, median is the best method. If that column has not any outlier, then you will can put the mean. But also beside this mean and median, you can also always put the mode also based on the values inside that column. Yeah, suppose if a column has 10 rows, and 9 rows are 1 and 1 rows is blank. So in 9 rows it has value 1. So you, in the missing value, you can't uh, directly average all the ones and find the median. So mode is the best case in this. But yeah, in categorical we usually treat the missing values and impute those value with the mode. So yeah, in data science, what I say is, there is always a scope of improvement, and there is still researches are going on. So there is no fixed path, or and like this is the only way. So it is based on your problem statement, and how far you can think, and what could be the best method. And yeah, people also usually do hit and trial methods. Sometimes they do one hot encoding, and they sometimes they do label encoding. And like, see, generally people say, yeah, like if we have ordinal data, we usually go for label encoding, and if we have nominal data, we go for one hot encoding. So yeah, that this is also not true every time. So you do hit and trial and see like how the model is performing, and which at which hyperparameters it is giving the best performance. So yeah, and hyperparameter also, there are so many values. So we have different technique like cross validation and randomized search, and we have different techniques to to get the best hyperparameters, and at which we can achieve the global minima. And global minima mean the cost function. So yeah, these are the things you should always keep in mind while solving any data science problem. So yeah, okay. So yeah, I hope everyone is clear with the things, and I think you might be having now a good knowledge about what is all about this healthcare industry, and how we can use this federated learning in healthcare. And so yeah, let's come to the conclusion then. So to sum it up, federated machine learning is like a helpful tool in healthcare, and help the different organization to work collaboratively without sharing their personal data. And without, and also ensuring the privacy also. So we have different application that we just saw in the PPT also. So it also help to keep the health data safe, that I told you. We have different tools and different techniques to keep our data safe with the help of encryption also, and different libraries like PySafe. We saw those libraries. So we can make our data safe, and also it helps, researcher work together, as I told you. So we can work collaboratively on different local machine. We can train our model. And yeah, if you are using the centralized, then you must not interact with the locals model. And if you are using a decentralized model, so those team, or you can say those organization, they can interact with each others, and they can update their model based on the previous model. And yeah, using resource smarter. Okay, then also it is making the resource smarter. So it makes clinical trial, as we talked. And yeah, finding new medicine more efficient. And by working together, we can, make healthcare more personalized and effective. So yeah, it is the federated learning is the, most efficient method, especially in healthcare. Suppose you have different hospitals, they never share data, because it's a, in today's world, we can say data is, gold of today's world. So usually people, they don't share their data, because it might leak, and the other might get benefit from it. So nobody is, want to share their data. So that comes, this federated learning comes into the picture to solve this problem. So you keep the data with yourself, with different organization. And yeah, train your model, and combine or aggregate your model, and make a global model. So yeah, and also improving health for everyone. So federated learning is, not just one for one hospital researcher, it's for everyone. So any organization can, you know use this technique in their machine learning uh, thing. And yeah, it helps us understand health trends in different places. But they can predict disease also, as we already talked, and even keep an eye on public health challenges. And yeah, we use this federated learning in COVID, very much, because every day, every state, they were having the different, corona patient. And so they were not they were reluctant to share their data. So at that time, this federated learning comes into the picture. So that was the best use case of this federated learning, COVID-19. And yeah, beside this healthcare, it is useful in different areas also. In IoTs also, people have started using this federated learning. So it's an emerging field. Everybody is talking about machine learning. So even still, some people, they don't have knowledge of this federated learning. And yeah, it's an emerging field. So it has been used in IoT also, in cloud computing also they are using. So it can be used in different areas of healthcare also, as we're talking about healthcare only. So it's we can predict, health issues, watching out our disease, like this disease will, we will suffer with disease in future or not. So we can also predict that, or figuring out how medicine work together. That we saw, those medicine, they should not connect with each other and form a compound that might impact the public health. So we can watch out that also. And so federated learning, it's a versatile tool, that can be used in many areas of healthcare. And yeah, it is very flexible, as we saw. So based on the model we choose, centralized, decentralized. So it's very flexible. We can keep our data private, and yeah, adapt to different needs. So yeah, that's we came to the conclusion now. So yeah, so let's come to the Q&A. So if anybody has any query, any question, yeah, feel free to ask. Yeah, I'll be happy to answer them.
Dear participants, if you have any questions, please ask.
Yeah, definitely. If you have any question, definitely you should ask.
Good evening, sir.
Good evening, sir.
Hello,
Good evening.
sir. Am I audible? This is Mahinder from Gitanjali College of Engineering and Technology.
Yeah, hi, Mahendra. Yeah,
Sir, it's a very good presentation, and you have given so many insights and inputs regarding this federated learning. Actually, I
yeah.
doubts attending the session, and all those doubts are cleared by going through this session, sir. And thank you very much for your great
Thank you,
session.
thank you,
And sir,
thank you
coming
so
to the
much.
coming to the
Yeah,
questions, I have two questions, sir.
yeah.
So one is when you are means what kind of parameters that will pass from our local means a decentralized location to the central location, sir, and what kind of input that will be fed to our global network. That is my first question. When coming to the second
Okay,
question,
okay.
in actually you said that horizontal and vertical federated learnings are there, so they
Yeah,
we use some samples and features, right? Whereas
yeah.
coming to the image processing, so here there
Hmm.
we are not aware of these the features and samples what are there in when we are training the model. So in such
Yeah.
case, what kind of federated learning method that we use to process images in this healthcare?
Okay. So Mahendra, let's come to your first question. So
Yes,
first question is your like what parameter should we pass to the global and what input? So okay. So it's not like we are passing from centralized to decentralized. Centralized and decentralized, they are different techniques. Okay. So they are
yes,
don't combine them. They are different technique based on your problem statement. You can choose one based on your client requirement. You can choose one, and when we are passing the models parameter. You can say, um, suppose you are using linear regression. Suppose you have 10 system and you are training a model on linear regression, and because linear regression is a simple, so that's why I would say that. So in linear regression, what do you generally find out?
means values means some do some predictions, right?
Prediction. Yeah, we do prediction. What are the parameter we usually find in linear regression? So in linear regression, we generally find the coefficient of the variables. That is, y is equal to mx plus c.
Yes, yes,
So
exactly.
we suppose y is equal to m1 x1, m2 x2, and m3 x3, and so on, and c. So we find those values m1, m2, m3, and c. So m1, m2 are slopes, and c are the coefficient, the intercept.
Yes,
So
sir.
these are the parameters. If we pass the value of x, and with the help of m1, if suppose you have m1, m2, and c, and you pass m1 x1 plus m2 x2, and x1 x2 you pass, then you can directly get the value of y. So in the
Yes.
global model, you will pass the models parameter, that the output of the individual models, that is the m1, m2, and c.
Okay. But based on these parameters, how can we do the predictions at a central level or global level? Means we are not giving any input to input parameter, input values to the central model, right?
No, in global model we will pass the value. We will test the model. Suppose in one model we have m1, we got at 10, suppose, and in another model, local model, we are getting suppose m1 as 20, say, for example. So when you will pass the parameters to global model, you will take the average of 10 and 20. That will be 15, right? So in
Yes.
global model, 15 will pass, 15 x1,
Okay,
right?
okay.
And if you
Right.
pass the input, suppose you are predicting if a person has diabetes or not. So maybe it depends on the data. The inputs will depend on the data. If you have trained the model maybe on the blood pressure, say blood pressure, you have trained the model. So
Yes,
at the global level, you will pass any random that blood pressure, that is x1. So suppose your pressure is maybe say 90. So what you will do is 15 into 90 you will do, and you will apply the sigmoid function,
yes, sir.
right? You will apply the sigmoid function to convert that value in between 0 to 1. That's
Zero
how
one.
you
Yes,
predict at the global level.
yes, sir. That means this the same data is divided into training and testing at a global level, sir.
Yeah, same. Yeah, same.
Okay, sir.
Same
Right.
data. Like 20% we will keep, or 25% on the global level,
Yes,
and another data sets on the local level, and we will
right.
test the data on those, and we will evaluate that global level based on the classification regression problem. Like if it's a classification, we have you might have the accuracy, precision, recall, and in regression problem, those MAE, MSE, those cost function. So you will analyze those and evaluate those based on the problem.
Yes, sir. Follow. Understood, sir. Sir, coming to the
Got it?
second question, my second question.
Yeah. Could you please repeat your second question once, Mahendra?
Actually, how do we apply this federated learning on images, sir, the medical images?
Okay. Okay.
Because
So
you said that in horizontal and vertical, we use the parameters and samples data different.
See, Mahendra, researches are still going on the computer vision in the federated learning. People generally use this tabular data only for now, but
Okay.
people are not able to find the a better solution for the image one,
Yeah.
because in
Got.
image we have different pixels. So
Yes, sir.
suppose you have say cat and dog, a simple example we will take cat and dog. So in cat and dog, what you can do is you will divide the data first.
Yes,
Okay,
sir.
you will divide the data into 2080. You will keep the data 20 at the global level,
Yes, sir.
and 80% of the data will divided into these at the local level.
Yes.
And we will train the data. We will train the data in such a way that it will it will predict the cat and dog exactly.
Yes.
So it's again a classification problem.
Exactly. Yes, sir.
It's again a classification problem if you are predicting. So you are passing the images of cat and dog at the local level,
Yes.
right? So
Yes.
what you will do is you will then again evaluate the data,
Yes.
right? Again evaluate the data.
Yes, sir.
And on how will you evaluate in classification?
Evaluation means we use some parameters, right? Accuracy.
Yeah, those are evaluation metrics, not parameters, evaluation metrics.
Yes,
So
sir. Yes.
accuracy, precision, recall,
Yes.
you will test it, and you if you are if your precision recall is very less, you again retrain the data.
Yes, sir.
Again retrain the data. And if you are using suppose ANN, suppose ANN in classification ANN, then again what you will pass. So it's a multi-layer perceptron.
Yes, sir.
That is a combination of weights and biases. So here
Yes.
weights are the parameters.
Yes, sir. Parameters. Yes.
Yeah, weights. So now you will pass the weights of that, and you will use the activation function. Maybe
Yes.
sigmoid you can use. You have
Relu.
yeah,
Yes.
yeah, step function. Those are different activation function. So you can use that. So we'll pass the weights, you can say, to the global level.
Yeah.
And at
Understood,
the
sir.
global level, that 20% test data set, we will run the model on those parameters, and we'll see if it is able to predict it rightly or not, if it is predicting cat as cat and dog as dog or not.
So if I'm not wrong, means the training is taking place only at the local level, sir. Training or training and texting both are taking place at local level.
Yeah, local only. Yeah, training will happen in local only, then they will aggregate their output or parameter at the global level.
Okay. Right, sir. Thank you, sir. Thank you so much.
Yeah, thank you. I hope I've cleared your
Yeah,
query.
clear. Thank you so much.
Yeah, thank you.
Thank you, sir. Sir, I have a question, sir.
Yeah.
Actually, I'm doing research in the same area, sir.
Hmm.
Uh, so, like, what I need is like, suppose I want to do the setup. I mean
Okay.
to say, like, what are the requirements, or like, what I need to have? Uh,
See, first you need local systems.
yeah, sir.
Don't try to build something at a production level, because you can't. You want a different local machines.
Yes,
As I
sir.
mentioned, hospital one, they have their different data, so
Yeah.
they will have their local machine.
Yes, sir.
then
Yeah.
then hospital two, they will have their
Okay.
local system. They will
Okay.
train that model there only, so you will require different local. You can't do it on your local only. Then again it will become a machine learning problem only, not federated. Federated means division of, laptops or models.
Yeah. So, like,
So you,
let us suppose, sir, like, suppose we are sending a model to
mm,
the nearby devices. So, how this selection will happen, sir? Like, I have that question in my mind. Like, how they will select a particular device? Like, we need to go to that device only, then we need to like do machine learning at that local device. Yeah. Like, how
that
server will
device
decide?
means,
How server will decide? Like, these are the devices that need to cooperate
see,
in doing machine learning, sir.
okay. See, what we usually do is, on the server level, we connect the local to the server using SSH key, secured
Okay.
shell.
Okay.
So we do that. We generate the public key on each local computer, public key,
Okay.
and
Okay.
we'll register those public keys on the server.
Okay.
Okay, then again, when you create the key on your local system, it will create public key and private key both. So when
Okay.
you pass the public key on the server, so it will, public key and private key are the complementary of each other. So when you pass the public key over there, so it will try to connect with your laptop, and it will try
Oh,
to fetch that private key. If it is able to get that private key, then only
okay.
you can, have the connection with the server.
Okay.
You
Okay.
got my point?
Uh, yeah, yes, sir. Yes, sir. I got the
Yeah,
point. Thank you, sir. Thank you for the
yeah,
answer, sir. Thank you.
yeah.
Yes.
Sir, sorry, sir, taking your time, sir. I have one more
No,
question.
no,
Extended
no
to
worries, Mahendra. Yeah, yeah.
sir, can't we create a local simulation environment in a single laptop by the tools which are explained, sir?
No, that you can't. See, what you can do is, you can create a virtual environment or virtual machine. Sorry, not virtual environment, virtual machine or your laptop.
Yes, sir. So
Then,
using some, yes,
yeah, that you can create, right? Virtual machine. Or
using
what you
virtual
can do is, have you used AWS?
AWS. I know the basics, sir. I'm not.
Okay. Okay. What you can do is, to solve this problem, you can create different instances on the AWS,
Okay, sir.
right? So they are providing, it's I think it's for 1 month or 1 year for free. So for free trial, you can create your instance or local machine on AWS.
Okay,
So
sir.
there'll be your one laptop and another will be of AWS.
Okay.
So you can create 2 or 3 instances,
Yes.
right? But you should be familiar with Linux commands, because you won't get the interface on instances on AWS. So you have to enter in the instances using commands. So
So
this is
or
how
else,
you can do it if you wanna,
or
if
else
you wanna
can we
try.
use sir, or else can we use a virtual machine so that we can add multiple operating systems in that? So by using these multiple operating systems, we create our local
See,
environment.
yeah, what I'm saying, like, is, you can, this is the same thing I'm saying. You can create virtual machine on AWS, not on your local machine.
Okay, sir.
Yeah, you can create instance. When I'm saying instance means virtual machine only on AWS server. You can
Okay.
create multiple instances. Yeah. So you can create 2 to 3 instances or local machine. You can distribute the data according to the to your requirement on those different machines, and your system, you can, make it as your main server if you are using centralized one.
Okay.
And then you can, where you will see, you will, create SSH key will, and you will try to connect those instances or those virtual machine with your laptop. That you can try.
Yes, sir. Understood, sir. Right.
Yeah.
Right, sir. Thank you so much.
Yeah.
Hello.
Hello.
Hello, sir.
Yeah. Hi.
Hello, sir.
Hello.
Hello. Hello, sir. Can
Hello.
you hear my voice, sir? I'm Jesh.
Yes. Yes.
Hello.
Yeah. Hi, Jashi. Hi.
Sir. Hello, sir. Sir, just now Professor Ganesh asked the question regarding the communication which is happening between the server and the local model.
Yeah.
Sir, regarding this, you just told that the public key is going to be given by the server to the
No,
local
no, no,
model.
no,
Is it
no, no, no. Public key, you will generate a key value pair. We usually see key value pair on your local system. Key value pair.
Yeah.
And you will key value pair means one will be public key, one will be private key. Right? So you have to, pass that public key to the server.
Yeah.
From your local to that server.
Okay.
And when you will do SSH using terminal from your local, it will automatically, you will pass the IP address of that machine, that server, then it will automatically locate your private key that is present on your local, and through this public and private key connection, you can build a connection between server and your local machine. But when you create instances in AWS, you need not to pass the public key. Because it automatically save your public key on that server, so you can connect directly.
Yes, sir. Yes, sir. So thanks a lot, sir. Thank you, sir.
Yeah, thank you so much.
Yeah. Still, the participants, if you have any questions.
Excuse me, sir.
Rohit, sir, one more question is
Sir,
there.
thank you, sir. This is Biren Kumar Saraswat from RKGIT, Ghaziabad.
Yeah, hi, Birendra. Yeah, hi, Birendra.
I'm fine, sir. And what about you, sir? Sir, this session is really very informative and practical session. But sorry, I couldn't attend from starting, so I miss a lot of things. But जितना सर मैंने सुना है ना, रियली दिस आई कांट से, मतलब मेरे पास वर्ड नहीं है सर, मैं कहना जो चाह रहा हूँ सर, रियली very wonderful session.
Oh, thank you so much, Virender, for your nice words.
Can you give me your number, sir, so that we can discuss a lot of things?
Yeah, I'll give it to the Shanti, ma'am, and I think you can get it from there.
Yes,
okay,
sir.
sir.
I'll be sharing with them.
Yeah.
Okay, sir. Thank you, sir.
Rohit, sir, one more question is there in chat box.
Yeah. Okay. Let me see. Okay, this we divide, label, and train and execute. What does this question mean?
I think that was an answer to some question. D. Bhu Lakshmi, are you there in Meet? She has a query like, is there federated deep learning? If it is there, what is the difference between them?
Okay, if federated deep learning, if it's there, what is the difference between them?
That's what the question she kept in the chat.
See, deep learning is a subset of machine learning only. Deep learning is a subset of machine learning only. So when I'm saying machine learning, that includes deep learning also. Deep learning and machine learning are not separate things. Deep learning is a subset of machine learning. So when I'm saying machine learning, that automatically means deep learning also. Deep learning, you can say, is a subset. That is an advanced version. In machine learning, we use perceptron, a single perceptron, and you can research like how it is different from logistic regression. So in deep learning, we use multi-layer perceptron. So if single perceptron, that is a machine learning. If multiple perceptron layers we are using, that is a deep learning neural network only. So there is no difference, between deep learning and machine learning. Deep learning is a subset, or you can say a special case of machine learning.
Ganesh sir?
Yeah, madam. Yeah.
Yes, sir, you can. I think no more questions.
Yes, ma'am. Okay. Thank you, sir. Your session was not only informative, but also incredibly engaging. leaving a lasting impact on all attendees, sir. So your depth of knowledge and expertise were evident throughout the presentation, and your ability to communicate complex concepts in a clear and accessible manner was truly commendable, sir. Participants were not only inspired by the content but also appreciated the practical insights and real world examples you shared, particularly the code part, sir. So, on behalf of the organizing committee and all participants, I want to extend our heartfelt thanks for you for your time, effort, and dedication in delivering such a memorable session, sir. Your willingness to share your expertise has undoubtedly enriched the knowledge and professional growth of everyone present. Thank you for sharing your expertise and contributing to the success of our event, sir. We hope to collaborate with you again in the future, sir. Over to
But
Dr.
definitely.
Shanti. Yeah, sir. Thank you, sir. So over to Shanti, madam, to end note and further brief you about tomorrow's session. Thank you, sir.
Thank you so much,
Hello,
Ganesh.
Shanti ma'am.
Yeah,
Hello,
thank you, Ganesh.
Shanti ma'am.
Yeah,
Hello, Shanti ma'am. Can you hear me?
yeah, I can hear you.
Yes, ma'am. Good evening, ma'am. Ma'am, will the video of today's session will be shared, ma'am?
Ma'am, it will be shared. As like yesterday's also, we kept in a group, ma'am,
Yesterday's,
WhatsApp group.
yeah.
We'll be
As like
sharing, ma'am.
yesterday's, today's also shared.
Yeah.
Yes, ma'am. Thank you.
Thank you, Ganesh sir, for inviting me. Once again, thank you so much, Rohit sir, for your valuable insights, expertise on federated machine learning in healthcare industry. I think I'm audible, sir.
Yes, Shanti.
Yeah. Dear participants, tomorrow we have Mr. Durga Prasad from Infosys, and he will discuss about the federated learning frameworks and the collaborative learning. Same time by 6:30 p.m. I hope all the participants definitely benefited through today's session. Once again, thank you all for your active engagement during the session. You can submit feedback before 9 p.m. today. Today's session also we will be sharing through YouTube link. Thank you all. Good night.
Thank you
Thank you.
everyone.
Ma'am,
Thank you everyone.
ma'am,
Thank you.
small request, ma'am. If you don't mind, can you please share PPTs, resource person PPTs?
Okay, sir. Yesterday's PPTs I got it, and I'll make a request to the Rohit sir also. Once he will share both the PPTs, I'll be keeping in WhatsApp group.
Yeah, thank you, ma'am. Thank you, Rohit sir.
Oh, thank you so much. Thank you so much, everyone. It was great. It was my pleasure to meet you guys and giving my industry insights. So yeah, it is my privilege to attend this session.
Thank you, sir. Thank you, Rohit sir. Good night, sir.
Thank you everyone. Good night. Good night. Bye.
Yes, Ganesh sir, we can wind up.